Hello everybody and welcome to this episode of Programming and Algorithms. In this episode we're going to look at the idea of variables. Variables are a very important idea in computers. They store data or information. So we like them because a lot of what computers is about is storing bank balances or records or student IDs or fees paid or employees, staff numbers or things like that. So we need what's called a variable to record that information. Thankfully, this is a concept that's going to be okay for us because we know the idea of variables from maths already. In algebra, we get equations like 2x minus 10 equal to 0. And then we know we bring the 10 across the equal sign. And that gives us that 2x is equal to 10. And then that x is equal to 5. In another problem, we might see that 3x plus 12 is equal to 0, so we bring the 12 across and change the sign. Then we know that 3x is equal to minus 12. Then we say that x is equal to minus 4. So that's exactly right. That's exactly how I like to think of a variable. A variable is an item that contains a value, and that value will change over time. Simple as that. Think of your bank balance. Your bank balance is a number, but that number changes over time. For me, my bank balance goes down, 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 down all the time, and then I get paid every once in a while. It goes up again, but then it goes down, 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 down towards 0 usually. So we need a place in memory to store that value, my bank balance or your bank balance or somebody else's bank balance. And that value that we're storing will change over time. Unlike in maths though, where you have to guess the value of the value of x, we don't do that in computers. We tell the computer program what the value of x is because we wouldn't want the computer to have to work out our bank balance. We need to tell them what it is. So we'll tell the computer by saying x arrow, let's say 5. So we read that as x gets the value of 5. So it's x less than minus 5, semicolon, because we terminate all statements with the semicolon. So that can be read as either x gets the value of 5 or x is assigned 5. How I'd like you to think about that though is, think of x as being a bucket or a barrel or something like that. So x is some kind of container, we'll say a bucket. And the bucket has the letter x written on the front of it. And we're sticking the number 5 into that bucket. Later on we could take the number 5 out and put the number 10 into the bucket. The bucket is still going to be called x, but we can change whatever number is in and out of the bucket. So that's how I'd like you to think of a variable. A variable is a bucket. Different kinds of buckets take in different kinds of things. We'll see that in a minute, but as long as we can focus on the idea of the bucket, both has a name on the front of it and a number inside it in this case. And if we say x is assigned 8 or x gets the value 8, then that means the number 8 goes into the bucket. We can also use an interesting command which says x gets the value x plus 1. What that means is whatever value is in x at the moment, let's say it's 4, overwrite that value with 4 plus 1, which is 5. So whatever is in the bucket x at the moment, 4, add 1 on and it gets 5. So we said that as x less than minus x plus 1, semicolon. And we can say either x gets the value x plus 1 or x is assigned x plus 1, or more commonly we say increment x, or x is incremented by 1. So that is to say we add 1 onto x. We can do x assigned x plus 2, x assigned x plus 10, x assigned x plus 100, whatever we want. But that means it has to know the old value of x and the new value of x. The old in this case is 4 and the new is 5. We could also create a new variable, another bucket, and let's say that bucket has the name y on the front of it. So if the bucket y is the same kind of bucket as the bucket x, the same kind of variable, then I could say y gets the value of x. So if the number 6 is inside the bucket x, then a copy of that 6 goes into the bucket y then. And we say y is assigned x, or y is assigned y gets the value of x. We could also say something like y gets the value of x plus 1. So if x is 6, that means y gets the value 7 in it, because it's 6 plus 1, if that makes sense. So we can do all kinds of arithmetic. We could add divide, multiply, subtract, whatever we want between the variables if we've got two variables. And we could use this, let's say if you're transferring money from my account to your account, we take the money from yours and put it into mine, so I'm X, you're Y. As well as integers, which is what we're talking about, or whole numbers, we can have a different type of bucket which takes real numbers, so numbers with a decimal place. And if we think about our bank balance, that's not a whole number usually, that's got a decimal place as well. Decimal place is how many pennies or pence or cents we've got in it as well. So my bank balance at the moment I think is £21 and 3 cents. So it's 21.03. So we can't use a whole number or integer to represent my bank balance. We need a real number or floating point value to represent my bank balance. So we can have a different kind of variable called a real variable, and that'll store numbers with decimal places. So if we were trying to, let's say, represent the value pi, we could have a variable called p, and we can assign it to be 3.14159. And we read that exactly the same way. The p gets the value of that, or p is assigned the value of that. When we think about it, if we just called our variables x, y, a, b, p, that would be very bad naming practice really, considering what we've said already, how important it is to give things a good name. So, although in maths we use x, y, a, b, c, in computer programming we like to give our variables bigger names. So instead of saying p gets the value 3.14159, we'll prefer to say pi, gets the value 3.14159, because that describes better what the variable is about. As well as number variables, which are either integer, which are whole numbers, or real, which are numbers with decimal places. We can also have a different kind of variable, which is a character variable. So a single character could be A, B, C, D, E, F, G. It could be the @ sign, it could be the full stop, it could be anything. So we can have a character which stores a character type bucket or a character type variable that stores values. So let's say we were trying to record different vitamins. We could have a bucket called vitamin. We could put the letter B into that and say this is recording vitamin B. So we'd say B gets the value, or vitamin gets the value of B, or vitamin is assigned the value B. Interesting enough, the number 5 can also be treated as a character. If I'm saying room number 5, let's say, and I'm recording what room we're meeting in, if it's room number 5, I actually want to think about that as a character, not as a number. With the number, typically I'm going to do multiplication, division, subtraction, things like that. Whereas with something like a room number, or a student number, or a bank account number, it doesn't make sense, let's say, to take your bank account and divide it by 5, or add 20% onto your bank account number. It doesn't make sense to do that. It makes sense to add 15% onto your bank balance or something like that, but not to the bank account number itself, or the room number, or student number, things like that. So to prevent us accidentally doing arithmetic on numbers that are meant to represent fixed values, or values that represent things like accounts or room numbers, we can declare those as a character variable as opposed to a numerical variable, if that makes sense. And that's really helpful then, because we can't start doing silly arithmetic on things. Another type of situation, exactly as I've said, the room number can get the value 2. And what we're saying there is it's a character 2. It's not the number 2. So we can't do any funny stuff on it like arithmetic. If we want to have more than one character though, that's called a string of characters. So the name is string. So if I can have a variable type called string, and that variable means I can put more than one letter, more than one character, more than one character representing a number, maybe an email address, something like that. Or in the example, if I have a variable called pet, so I've got a bucket, the name of the bucket is pet, I can put in the letters DOG for dog, and we'll say pet gets assigned the value of dog. I could change that later because it's a variable and change dog to cat, or dog to budgie, or something like that. but we're declaring a string of variables. There is one final special variable type. It's a weird bucket because it stores only one of two values. It either stores the words true or false. And that bucket type is called Boolean, named after George Boole, who was an Irish mathematician. So a Boolean type variable is a variable that will only store the words true or false. Let's say I'm recording for each student in the class, whether they're looking at this video at home or in work, or at home or in college or something like that. Then I might have a variable saying looking at videos at home is true or false. If it's true, they're looking at the videos at home. If it's false, you're looking at the videos somewhere else. So in the example at the moment, what I've said is it the weekend? And at the moment, I'm assigning that bucket the value false. So is weekend is given the value false, or is weekend is given the value true. So I might write a program saying, if today is Monday, Tuesday, Wednesday, Thursday or Friday, then is weekend is false. And I might say, if day equals Saturday or Sunday, then is weekend equals true. If that makes sense, is assigned true. So that's variables. And if we want to revisit the programs we looked at before to read in a number and print it out, we can restate that now that we know what variables are like, and say, to print out a number, we read in a value into a variable called value. So whatever the person types in, we stick it into a bucket called value, and then we use the command print to print out whatever is in the bucket. We don't print out the word value, we print out whatever number or character or boolean is stuck into the bucket called value. And the other algorithm we looked at previously was to say, read and print out double the number. So if we want to read in a value and print out double the number, we have a variable called value that we read in. We could create a second variable called double that value, and then we can assign that to be 2 multiplied by the value, and then print out the new variable double value. So we've got a bucket called value. We read in a number that a user types in. Let's say they put in 5. Then we create a new bucket called double value, and double value gets the result of 2 multiplied by 5, which is 10. And then the command is to print out whatever is stored in the bucket double value. We'll notice as well again that each command, each statement is followed by a semicolon, that the overall program and program name is followed by a colon, and the end of the command is followed by a full stop. And that's good to practice that kind of syntax, because unlike pseudocode, which is kind of designed for us, when we're getting to the programming language, if we forget a semicolon or a full stop or things like that, the computer will get very confused. It uses these syntactic elements, semicolon, the colon, the full stop, to understand where a command ends and where a new one starts and things like that. So we have to be very careful we do that correct. So the more practice we get into by practicing this style of using syntax in pseudocode, the better we will be at it. If we want to convert a temperature from being in Celsius into Fahrenheit, for example, there's an equation that explains how to do that, and the equation is the Fahrenheit value is double the Celsius value and add 30 on. So let's say, for example, if the Celsius value was 25, then the Fahrenheit value is 25 by 2, which is 50, add 30 on, which is 80. So 25 degrees Celsius is 80 degrees Fahrenheit. How would we express that as a program? If you want to pause the video for a second and think about it and write that out, what program name would we call it? We'd call it convert Celsius to Fahrenheit. What would we do? We'd read in a value. We'd read in the Celsius value, for example. And then we'd create the Fahrenheit variable by multiplying the Celsius value by 2 and adding 30 on, and then print out the Fahrenheit value. So what would that look like? You can pause and do it. All right. So here's how I do it. The program is convert from Celsius to Fahrenheit, colon. I've put in a printout statement, just imagining we're printing this out to the screen. Please input your temperature in Celsius. So then we'll read in a value called temp. We could read in a value called Celsius if we like, whatever variable name we like. And then we're going to print out that temperature in Fahrenheit is, and then we're going to print out temp multiplied by 2 plus 30, and then that'll give us our Fahrenheit value. So now we're getting into creating interactive programs where we're asking the user for input and printing out a value as a result of that input. Let's do it the other way around now. Let's convert Fahrenheit to Celsius. So we just switch around the equation, and Celsius is equal to Fahrenheit minus 30 all divided by 2. So based on the last example, if Fahrenheit temperature 80 minus 30 is 50, divided by 2 is 25, as we had done before. So what does that program look like? Well, it looks almost the opposite. Convert from Fahrenheit to Celsius, what do? We say, please input your temperature in Fahrenheit. We read in that temperature. Again, we could call that variable Fahrenheit if we like. And then we print out that temperature in Celsius is, and we print temperature minus 30 all divided by 2. The divide by symbol in computers is not the line with the dots either side of it. It's a slash that indicates division. And notice again how we end each command with a semicolon, and we finish off the program with an end full stop. So that's it for variables. I hope that makes sense. Please feel free to email me if you have any questions, and I'll encourage you to do that at all times. Thanks very much. We'll see you on the next episode.